In order to solve equations with three variables, so systems of equations with three variables, we will have different methods. The first method that we're going to introduce in this section is going to be called Gaussian elimination. In the next couple of sections, we're going to talk about ways to do Gaussian elimination using the calculator, so this method will sort of become obsolete. But the goal of Gaussian elimination is to write your system with the following format. So you want your first equation to be an equation with three variables, x, y, and z. The middle equation, you want it to not have the letter x. And finally, the third equation, you want it to have no x, no y. So you just want the z there. And once you know what z is from the third equation, you plug it back into the second equation to get the y. And now you have y and z. Then you plug it into the first equation to get your x back. That's the idea behind Gaussian elimination. Now, how do we accomplish this goal? The guideline basically says the following. You can interchange any two equations you want to accomplish your goal. You can multiply on both sides of one equation by a non-zero constant. So you can multiply one equation by any number you want. And then finally, you can add a non-zero multiple of one equation with another equation. So what does that mean? That means you can multiply one equation by a number and add it to a second equation to create your third new equation, basically. So let's go ahead and look at this process with example number 2. So we have three variables again, and we have three equations. And my goal is to leave the first equation with x, y, and z. And I already have it like that, so it's good to go. Now the second equation should be missing the letter x. So I want to somehow eliminate the letter x. Now to make something into a zero, here's what we're going to do. We're going to multiply another equation, for instance the first one, by a number and add it or subtract it from the second equation. So here's what I'm going to do. I'm going to call this one row 1, I'm going to call this one row 2, and I'm going to call the third equation row 3. So what is R1, R2, R3? These are the rows. And why am I calling them rows? Because I'm thinking of this like a cabinet. The first row, second row, third row, whatever. So what I'm going to do is this. I'm going to write down 4 R1. So what does that mean? That means I'm multiplying 4 by row 1. So that means I'm going to multiply the first letter by 4, the second one by 4, the third one by 4, and everything by 4. And I want to be able to add it to the second equation to kill the 4x. So not only do I need 4, I need negative 4. And I'm going to add it to the second row. And I'm going to put the answer, so that's what this arrow means. I'm going to put the answer back into the second row. So let me show you what that looks like. So when I multiplied the first equation by negative 4, I get negative 4x plus 8y minus 12z, and then negative 44. Now, row 2 is already 4x plus 2y minus 3z equal to 4. So far, if I add them up together, what do I get? Why am I adding them? Because that's what I told you I'm going to do. I'm going to add them up. When I do this, the x's will make each other go out, right? They will cancel each other out. And I get 10y minus 15z. And now I'm going to have negative 40 on the other side. So this is it, basically. This is the end. So far, row 2 is gone. I'm going to go ahead and get rid of it. And it's going to be replaced with that new one. So far, my system looks like x minus 2y plus 3z equals to 11. And then the second equation is now 10y minus 15z equals to negative 40. And finally, the third equation is still the same. We haven't touched it yet. And there it is. Okay, so that's what we have so far, So let me go ahead and write down over here. So far, this is what I have. So I'm going to just grab it and move it across to here. So that's the end of step number 1 in Gaussian elimination. We wanted the middle equation to not have the letter x, and we were able to do that. So again, in the future, if you want to cancel a number out, if you want to cancel out a 4x, like in this case, we wanted to remove the 4x, how do we accomplish that goal? We accomplish that goal by multiplying one of the equations by a number and adding it to the equation that we want. So let's see if you understood that. I want to get rid of the 3x next. So how am I going to do that? Well, the way I'm going to do that is by first multiplying one equation, for instance, the first one, by a number and adding it to the third one. Now I want them to cancel out eventually. So I already have 3x down here. To cancel it, I'm going to need to multiply the first equation by negative 3. So I'm going to multiply the first row by -3 and add it to the numbers in the third row. And I'm going to put the answer back into the third row. So let me again explain. So here's the first row. I'll multiply all those numbers by -3. So you get -3x plus 6y minus 9z equals to -33. The third equation is already 3x plus 3y minus z equals to 4. And again, I'm telling you that we want to add them. So let's go ahead and add the two equations with one another. What do we get? We end up with 9y minus 10z, and now it's -29. So that number, or that equation, is going to be replacing the equation number 3. So let me record what I have so far. So far I have x minus 2y plus 3z equals to 11, and I have 9y minus 10z equals to -29. Okay, so the first row is the same as before. The second row is the new one that I created, and the third one is the new one that I created also. So to recap, so far what have we done? So far we have started with a problem that had 3 equations, and we decided the first step is to get rid of the 4x in the second equation. So we multiplied the row 1 by -4, and we added to row 2, put the answer back in row 2. And we also decided that we would like to cancel out the 3x. So in order to do that, we multiplied the first equation by -3, we added the third equation, and we got our answer, and we put it back into row 3. Finally, the last thing we got to do before we are done with this Gaussian elimination is to remove the 3y right there. So how am I going to remove the 3y? Well, in order to remove the 3y, I have to look back at what I have done so far. This is what my current system looks like. And the 3y is now gone. It's been replaced somehow with the process with 9y. So the 9y is what needs to go, right? So how can I remove the 9y? I gotta multiply one equation by a random number and add it to this one to cancel it out. Now, if I multiply the first equation by a random number and add it to the third equation, it's gonna create an x right there. And I don't want that. So what I'm gonna have to do is I'm gonna have to focus on the second equation. So what number should I multiply that guy by and add it to this guy by to make them become 0? Well, it's a little bit tricky here, but what I have to do is I have to multiply the second row by the numbers 9/10 with a negative sign. Why is that? Well, because if you multiply -9/10 by the 10 that's already in the second row, the answer will become -9. And then when I add it to the 9y, things will cancel out and I will get my goal. So unfortunately, that's what I have to do. I have to multiply by fractions, but remember, you have calculators, so you can use your calculator for now. And this is not the way we're going to do things forever, but we're doing it like this for today for this section. So I'm going to add that to answers, the answers to row 3, and I'm going to put the answer back into row 3. So use your calculator to multiply the middle row by 9/10 with a negative sign. And tell me what you get. So I'm not sure if you did this right or not, but take a minute to pause the video if you haven't done so and figure out what the numbers are. I get these numbers. I get -9y plus 27/2z equals to 36. This is what I get when I multiplied the middle equation by the -9/10. Now remember, the third equation is already the same, so I'm just going to copy it down. 9y minus 10z equals to -29. And I'm going to go ahead and add them up together again because I'm saying I would like to add the two equations with one another. And when I do that, what's my solution going to be? Again, you can use your calculators to do this step. So I get 7/2 z, and then I get 8 on the other side. Oh, sorry, I meant to say 7 on the other side. Okay, so let me go ahead and record what I have so far. So my system is this guy right here, but it's been changing throughout the problem. Okay, now we have an updated third equation. So let me go ahead and copy it and just say, okay, well, the third equation is now different. It's no longer what it was. Now it's 7/2 z equals to 7. So 7/2 z equal to 7. And this is the end of the process that we call Gaussian elimination. Now, this is not the end of the problem. This is just the end of the process where you modify the system and notice how there are no more x's right there, there are no more x's right here, and there are no more y's right there. And that's the whole point. We don't want the x's or the y's or the z's in that order. So at this point, we're going to look at the third equation and try to guess the z. So from the third equation, I know that, so it says right now that 7 over 2 z is equal to 7. So how much is z? Well, it must be 2 for it to work. And you could do that with a calculator. You could divide the 7 by the 7/2 fraction and you end up with 2. But now that I know z is 2, but I remember that in the second equation I had 10y minus 15z equals to negative 40. Well, if I already know what z is, couldn't I use that information to get the y? Yes, I can. So grab the number and plug it into the z, and you end up with 10y minus 15 times 2 has to be equal to negative 40, which means that 10y minus 30 has to equal to negative 40, which means that 10y has to equal to, add them up, you get negative 10, which means y is going to be negative 1. So now I know what y is. Remember, I'm still missing the x, so all I have to do now is use the third equation that has the letters x, y, and z to get the solution. So when I use the third equation, I just have to keep in mind that y is negative 1 and z is 2. So when you plug them in, make sure you plug them in the right places. The y goes first because that's the letter y, and the z goes last because that's 2. So in this case, we get x plus 2 plus 6 equals to 11, and I'm looking for x. So I'm going to do 11 minus 6 minus 2. So basically 11 minus 8 is going to be 3. And so the solution for this problem is going to be the letter x, 3, the letter y, negative 1, and finally 2. That's what we call Gaussian elimination, and then solving the problem.